A function rule. We have a 400-page book. He reads 4 pages every 5 minutes. So my function rule is going to be f of x equals 400 pages. And when I read pages, what's going to happen?
They're going to go away.
So I'm going to subtract 4 pages every 5 minutes. That's it. Okay, so that is what should go under function rule. Now I need to change that into standard form. So I'm going to go y equals 400 minus 4/5 x. Multiply everybody by what?
5.
By 5. So multiply by 5. So we got 5y equals 2,000 minus 4x. The 5's cancel. Where does the 4x need to go? In the front? So I need to add it to both sides. Plus 4x plus 4x. And I end up with 4x plus 5y equals 2,000. Okay, we get the x-intercept by covering up the 5y. And 4 goes into 2,500. What does that mean? It takes 500 minutes to finish the book. Thank you. And the y-intercept is the number on the end, or you can cover up the 4x, and that gives me 400. Oh, look, the 400 is right there, too. And that is the starting what? Starting number of pages. The slope. Which form can you see the slope in? The function rule right here, I can see it right there. It's 4/5. Actually, it's negative. Negative 4/5. And basically, I can just copy what it says. He reads 4 pages per 5 minutes. Do you think this is discrete or continuous? Discrete, because we're counting pages. If my graph is discrete, then my domain is going to be numbers like 0, comma. How many pages? Do we want to read 1 page at a time?
No.
How about 4 at a time? Well, I like 100s. So I'm going to go 100, 200, 300, 400. Why did I stop at 400?
Because that's the end of the book.
That's the end of the book. All right, now if I plug in these numbers, what I did over here is on mine, I took and made a table. So I went 0, 100, 200, 300, 400. Of 0, I have 400 pages left. After 100, I just do 100 times 4/5 and subtract from 400. Are you following me?
Yeah.
I don't know if you are or not. So I'm taking these numbers and I'm plugging them in. 400 minus 4/5 times 100. I would just type that in my calculator that you don't have right now. And that gives me 320. Okay, then the next one, I do the same thing and I change this to a 200. 200 gives me 240. What are we decreasing by each time? Going down by 80. So 300 is going to be 160 and 400 is 80. Uh-oh, and after 500, how many pages do I have left? 0. So yeah, those minutes. I had those 2 backwards. Okay, is it linear? Oh wait, time out. My range is going to be in order 0, 80, 160, 240, 320, and 400. It's the range that can't go over 400. And I should have my domain. I should have a 500 here, shouldn't I? All right, is it linear? The reason it's linear is because we have common differences for x and y. Is it direct variation? No. Does it pass through 0, 0? The y-intercept would have to be 0, and that goes through 400, so not 0, 0. Okay, write an equation and solve to find out how many more days until 225 pages are left. This is really important, so don't just ignore this one. Okay, so I have to take my formula, 400 minus 4/5 x, and I want to equal 225. Does that make sense? I just take the 225 and plug it in. So I need to subtract 400 from each side. And that gives me negative 4/5 x equals, I'll tell you what that is, 175. And then now what do I need to do to start solving? Times by 5. Oh, yep. Thank you. And so then that gives me negative 4x equals negative 875. 175 times 5. Divide by negative 4 on each side. And x is 218.75 minutes. Okay, so how many minutes is that? Can I go down to 218 or do I have to go up to 219? 219 minutes. Okay, now 27 we just did together. Uh-oh, that's bad. That's my fault. That should say minutes. Ooh, how many days is 219? Can't figure that. It's not even a whole day. Okay, so what was our inequality for 27? Y is greater than, because it's shaded above. The slope is up 1, 2, 3, 4 over 1, 1, 2, 3, 4 over 1. So the slope is negative 4x.
What about the graph?
And then minus 5. Yep, we got to go graph this one. I went down too far. Okay, so when I'm graphing this, y'all listen, it's way easier to graph using the standard form and the x and y intercepts. What was your x-intercept? Isn't it 500? So I'm going to go by 100s. 100, 200, 300, 400, 500. And then my y value is going to be pages. And my y-intercept is 400. I'm going to again go by hundreds. So it's 100, 2, 3, 400. Looky there. Then all I have to do is connect the dots. Okay, so on these problems, it is easier to use intercepts by graphing. Okay, 20, where are we going? 28. The graph of a line that contains those points is shown below. Write an equation that best represents this line if the slope is doubled and the y-intercept remains constant. What is the slope right now? There's a point, there's a point, up 2 over 1, up 2 over 1. So my slope is 2. Does that make sense? And my y-intercept is what? Right there at negative 3. So it tells me I need to double the slope. So what's the new slope going to be? 4, and keep the y-intercept the same. So that's going to be y equals 4x minus 3. 4x minus 3. Okay, 29. Orlando wants to plant tomatoes and peppers. Tomato plants cost 2 each. So how am I going to write that down? 2x. Pepper plants cost 1 each. 1y. How much money does he have? No more than 15. No more than. What's that? Less than or equal to. No more than 15 is less than or equal to 15. Okay, now I'm going to graph it. What? Sure. Yeah, you can just leave it y. Okay, now my y-intercept, my x-intercept is going to be what? Cover up the 1y. 2 goes into 15. 7.5. And this is going to be tomatoes. My y-intercept is going to be peppers. How many peppers does it have? 15. Is it dotted or solid line? Solid line. And where do you shade? Underneath. The end. Now,